Hey everyone, this is iTower. Today we're diving into one of the most fundamental and efficient search algorithms out there, binary search. It's a classic technique that comes up often in coding interviews and is widely used in real-world software, especially when you're working with sorted data and need to find something fast. So in this video, we'll explore not just how binary search works, but why it works, what makes it powerful, and where its limitations are. And of course, we'll walk through the code step by step together. Before we begin, make sure to like this video and subscribe to the channel. It really helps me keep making useful content like this for you. And you won't miss anything new if you hit that bell icon too. Alright, let's start by understanding the core idea. Binary search is a searching algorithm that works only on sorted arrays. The basic idea is to divide the search space in half every time we check. This is what makes it so fast. Instead of going through every single element one by one, like in a linear search, we repeatedly check the middle of the current range. If the middle value is equal to our target, we're done. If it's too big, we ignore the right half. If it's too small, we ignore the left half. And we keep repeating this until we either find the value or the search space becomes empty. So essentially, we reduce the work by half on each step. Let's now write this in JavaScript. We define a function called binarySearch, and it takes two inputs, a sorted array, and the number we want to find. To begin the search, we need two pointers. One will start at the beginning of the array, and the other will start at the very end. So here we set left to 0, that means the first index in the array, and right is set to the total number of elements in the array, -1. That gives us the index of the last element. Now we create a loop. This loop continues as long as the left pointer is smaller than or equal to the right pointer. We write this condition because if left and right point to the same index, we still need to check that one final element. Inside the loop, we calculate the middle index between left and right. So what's happening here is we add the values of left and right, then divide that sum by 2. That gives us the index in the middle of the current search range. We wrap it with the floor function to make sure we get a whole number in case the result is not a perfect integer. Now we check whether the value at that middle index is exactly what we're looking for. If this condition is true, it means we found the number and we return its index. But what if the value at the middle is bigger than the target? This means that the number we want must be somewhere before the middle. So we move the right pointer one step to the left of the middle, reducing our search range. Now the opposite case, if the value at the middle is less than the target. Here we move the left pointer one step to the right of the middle because we know our value must be somewhere after the middle. If the loop finishes without finding the value, it means it's not in the array, so we return -1. Returning -1 is a common way to say that the item doesn't exist in the array. Let's test this with an example. We create a sorted array with some numbers. Now we call our function and search for the number 10. Arrays start from 0, so the index is 4. And when we run the code, we get 4 in the console. That means the algorithm is working perfectly. Let's talk about performance. Binary search has a time complexity of logarithmic order. That means that even if the array has 1,000,000 elements, it only takes around 20 steps to find something because each step cuts the search range in half. It's much faster than checking every item one by one. But when binary search won't work, there are some limitations. First of all, it only works on sorted arrays. If the data is not sorted, binary search simply won't work. You would have to sort it first, which can take extra time. Also, binary search needs direct access to indexes like in arrays. It doesn't work well with data structures like linked lists where jumping to the middle is impossible. To wrap it up, binary search is a powerful and efficient way to find items in a sorted list. It's a must-know for coding interviews and a great example of how we can use logic and structure to improve performance. If you enjoyed this video, please hit the like button and subscribe to iTower for more content just like this. And if you have any questions or want to try your own versions, let me know in the comments. I'd love to hear your thoughts. Thanks for watching, and see you in the next video.